All right, so we can get started now. It's after 1:30. Hello and welcome to the 41st Great Lakes Phragmite Collaborative webinar, part of our Students of Phrag webinar series. My name is Patrick Hanneth from the Great Lakes Commission, and I'm hosting the webinar today on behalf of the Great Lakes Phragmites Collaborative. Our presenters today are 4 students from Wilfred Laurier University: Brianna Downey, Jacqueline Haynes, Ariana Mansing, and Nita Rashidi. They will be presenting on their work using aerial imagery to map Phragmites in Lake Bernard, Ontario. Before we get to our featured presentation, there are a few housekeeping items to review. The Great Lakes Phragmites Collaborative is a partnership to link people, information, and action on invasive Phragmites. The collaborative is coordinated jointly by the Great Lakes Commission and USGS Great Lakes Science Center, with funding from the Great Lakes Restoration Initiative. The collaborative facilitates communication among stakeholders across the region, and we assist in the development of management tools and programs, and serve as a resource center for information on Phragmites biology, management, and research. The collaborative is led by a multi-agency advisory committee and applies principles of collective impact to advance a common agenda for Phragmites management in the Great Lakes region. Another way the collaborative engages with Phragmites professionals is through the Phragmites Adaptive Management Framework, or PAMF. PAMF utilizes participatory science to provide data-driven Phragmites management guidance through an adaptive management framework. What that means is that we have established a way to learn from what Phragmites managers are doing and turn that data into annual guidance to help managers make effective and efficient management decisions. We encourage anyone currently managing Phragmites in the Great Lakes Basin to consider joining PAMF. We are planning to host a live virtual training session on May 25th from 10 to noon Eastern to help interested managers get involved. Registration information is available on our website, but please reach out to us at pamf@glc.org if you would like additional details or would like to hear more about the program. In addition to our live virtual training session, we'll be launching a self-guided training resource through the Moodle learning platform at the beginning of April, so that is available. The Great Lakes Phragmites Collaborative recently released its Common Agenda. The Common Agenda is the first big step we are taking to align our regional goals and establish a shared vision for change. The purpose of the Common Agenda is to clearly define the intentions for the collaborative, develop a shared understanding of gaps and problem areas surrounding Phragmites, and highlight the areas and strategies that we are working on or wish to work on. We recently hosted a public briefing that discusses the Common Agenda, provided an update on recent collaborative activities, and outlined steps that we would like the Great Lakes Phragmites community to take in order to help us advance our Common Agenda. A recording of that webinar is available on our website. There are also several steps that you can take to help us continue to make progress on our Common Agenda. First, we are asking Phragmites managers in the region to participate and encourage others to join PAMF. After completing the training, PAMF participants with one management unit typically spend about 3 to 5 hours annually to participate in PAMF. The small time investment can have a large impact on our collective learning effort and help managers across the region. I know a lot of you joining us today have many years of Phragmites experience or research experience as well. If you have resources that may be helpful to other Phragmites professionals, consider sending those resources out through our listserv or sending them to us at phragmites@glc.org for us to host on our website. Considering how widespread of an issue Phragmites is, both geographically and in terms of its impacts, learning and sharing information on managing Phragmites is going to give us all the best chance of success. And we would like to encourage you to coordinate management efforts with others in your area. Finally, consider how your activities or the activities of your agency could be aligned with the collaborative. We would like to hear from you on how your work can contribute to advancing the Common Agenda and what we can do to facilitate that. If you're interested in learning more about the Phragmites management and research, you can check out the resources on our website, which include management guidance and recordings of past webinars. You can also join our listserv to connect with hundreds of other professionals and sign up for our bi-weekly newsletter, which includes a quarterly research roundup of academic papers published in the previous 3-month period. You can find links to join the newsletter and listserv on the front page of our website. And that's our website right there, Great Lakes Phragmites.net. Today's webinar will be recorded and uploaded to our YouTube channel and website. You can access an archive of past presentations on our website. You can also view and register for upcoming webinar presentations by following the URL listed here. So hello to those who are watching the recording after it's published. Please share with your colleagues and don't hesitate to reach out even if you're watching this long after the presentation date. And of course, connect with us on social media and tag us in your Facebook and Twitter post at GLP Phrag. To help our webinar run smoothly today, I will now go over a few technical reminders. Audio for this webinar can be streamed through your computer speakers or a telephone. To use a phone line, find the call information in the meeting connection materials that were sent out prior to the start of the webinar. It should be an email. In order to minimize the potential for interruptions and background noise, we have automatically muted all attendees. Please keep yourself on mute with your cameras turned off to save bandwidth. Thank you. If you're experiencing technical difficulties, please send a message to our email at phragmites@glc.org. Questions may be submitted at any time during the webinar using the chat feature. Our speaker will answer all questions at the end of the webinar. We will do our best to take all questions or comments during the webinar as well. If you need to leave the webinar before we have gotten to your question, we encourage you to review the webinar recording that will be posted on our website to hear your question and the answer. All right, now it's my pleasure to introduce our presenters. Our speakers today come from Wilfred Laurier University in Ontario. Brianna Downey and Nita Rashidi are 4-year environmental studies majors, and Ariana Mansing and Jacqueline Haynes are in their 3rd year in the environmental studies major as well. So thank you so much for sharing your work with us today. I'll transfer presentation control to you now, and please take it away.
Hi, thank you so much for the welcoming introduction. We are very excited to be here, and we are grateful to everyone joining us today. Our research consisted of the spatial analysis of the common reed Phragmites australis in Lake Bernard. This was our research project for our field studies course. Unfortunately, COVID restricted the course to be virtual instead of physical instead. Moving on.
Hello, my name is Ariana Mansing, and I am Honors Bachelor Arts in Environmental Studies with a Geomatic option and a Sociology minor.
Hi, my name is Brianna Downey. I am an Honors Bachelor of Science student majoring in Environmental Science and minoring in Biology and Geography.
Hello, everyone. My name is Jacqueline Haynes, and I am an Environmental Studies student. I'm also pursuing the Geomatics option, as well as a minor in Archaeology and Heritage Studies.
And I'm Nita Rashidi. I'm an Honors Environmental Science student.
The purpose of our study is to conduct a spatial analysis on the distribution of Phragmites in Lake Bernard, which is a freshwater lake located in the Strong Township of Ontario. Freshwater lakes are extremely valuable natural resources that provide numerous different services, both economic, ecological, and sociological, such as preventing shoreline erosion, providing habitats for numerous different species, and aiding in sediment deposition. While invasive species such as Phragmites disrupt these ecosystems, such as changing the soil chemistry, changing nutrient cycling, and hydrological cycle. So some background understanding is that Lake Bernard isn't the only area affected by Phragmites, of course. This is a widespread problem all across North America, and this is linked to its ability, Phragmites' ability to tolerate a wide range of environmental conditions, and it has different means of reproduction, such as seed dispersal or ribosome expansion. Therefore, mapping the current distribution of invasive species is important to aid in monitoring and implement control measures. With this in mind, we did remote sensing approach because it's cost efficient and we already had this data readily available. In this study, we used UAV, which stands for Unmanned Aerial Vehicle Imagery. This was used to map the spread of invasive Phragmites in Lake Bernard and to allow an assessment of the distribution. And on this map, you can see there's a little red diamond right here, if you can see my cursor, that indicates about the area of where Lake Bernard is. So our study site is Lake Bernard, which was once deemed the largest freshwater lake without an island. This title is now subject to controversy due to Phragmites creating an island within the middle of the lake. The study site, as you can see, we have 6 different study sites, most of which on the west coast of Lake Bernard, with 1 on the east coast. The east coast study site serves as a control measure to show an area without Phragmites to allow comparison of the health of the vegetation to areas with and without Phragmites. This sampling was done with the idea or the understanding of areas that have a high density of Phragmites. We also use additional data sourced from Scholars Geoportal, which focus on the area around Lake Bernard, allowing overlap from our 2018 and 2019 data. And as mentioned before, we used UAV. With UAV in mind, we have to consider the GSD. GSD stands for ground sampling distance, where this controls or indicates how detailed the image is and how detailed the spatial resolution is. The lower the GSD, the higher the resolution and the higher the detail. In addition, we also took all the data is mainly in October, which is the fall season, which aids in differentiating the native species from Phragmites.
All right, so moving on to the study objectives. So in our study, we mainly wanted to concentrate on Phragmites characteristics, specifically looking at the spatial distribution of common reed near Lake Bernard, as well as identifying potential factors that contribute to its spread. We also looked at the vegetation health in the surrounding area using the existing UAV imagery from fall 2019. This imagery was used to classify the vegetation health based on chlorophyll levels given by the Normalized Difference Vegetation Index, or otherwise known as NDVI. So since the data we took was from the fall, it actually worked to our advantage because Phragmites has a high NIR response in the fall, allowing it to be easily distinguishable from the other native vegetation. Moving on, I'll continue on with the methodologies. So as mentioned, due to COVID-19, our class was not able to actually go out to Lake Bernard and conduct fieldwork ourselves. However, we did obtain secondary data, which I'll share their methodologies. So this data enabled us to analyze the area in multiple ways, and it was gathered by the EB UAV. So this is a fixed wing UAV, therefore it is resistant to less than ideal weather conditions. And it is a drone that allows a camera to be inserted to provide aerial photos. The images are captured and then integrated together to produce a map of the sample sites. The camera that was used was the Canon PowerShot S110, which allows for false color imagery, as well as SOTA, which is a camera model that was used on the site and allows for 3D mapping of the images. These allowed for imagery in true color RGB as well as near infrared. So now I will show you what the raw data looks like. Right here is just a sample of what we had. So in total, we had 6 sample sites. However, these are just 2 from the 2019 quality report. So the image on the left represents the DGI beach location captured from the west coast shoreline of Lake Bernard. In total, 70 images were captured to make this image, comprising of 102.1 megabytes. On the right, there's the NIR2 imagery, which was also captured from the west coast shoreline, and the image consists of 51 images in total, which is 855.2 kilobytes. So the analysis procedures for our projects were conducted using ArcGIS and ArcGIS Pro software. We obtained our data through DSM and TIFF files, as well as orthographic images. DSM stands for Digital Surface Model, and TIFF is a raster dataset. The files are used in ArcGIS as an image importing method, used for image editing applications. To capture images, as mentioned, SOTA was used, which is the sensor optimized for drone application. And overall, there were many different applications and tools via ArcGIS and ArcGIS Pro, which through individual analysis, our group was able to gather a wide variety of evidence for our project. Using Image Classification Wizard on ArcGIS Pro, we were able to extract information classes from the multiband remote sensing. The site was classified by various land cover types to achieve an accurate visual representation of the geographical distribution of Phragmites in the area. The spatial analysis techniques that were used in our project include the use of near-infrared imagery to capture the Ndvi, which allows us to measure the chlorophyll levels present in the vegetation, which is an overall indication of forest health. We also used Vari, which is the visually atmospherically resistant index, and conducted an array of proximity analysis using buffers, as well as finding the kernel density estimate and the nearest neighborhood analysis. Ultimately, this would allow us to look at the downstream effects of Phragmites on Pool Lake.
So as you can see here, I already shown this image of the study sites in Lake Bernard. We also attached imagery associated to each study site to allow the audience to be able to differentiate what study site looks like what and where everything is. So hopefully this aids in some confusion. We will mention it in our analysis what area we are looking at though. So now moving on to our results, such where we present our analysis.
This is a comparison of the shoreline study sites in Lake Bernard from the years 2016 and 2019. Overall, it appears that the shoreline vegetation has been altered within the 3-year span. The 2016 Central Ontario Orthophotography Project 4 bands cover a large area of southwestern Ontario. This data set produced a raster elevation to create a representation of the surface and ground features. The 2019 images were provided by the 2019 UAV Laurier Field Course. These images from 2016 were collected in the summer, while the images from 2019 were collected in the fall. Therefore, vegetation patterns appear different. However, if ignoring the coloration of trees, the presence of shoreline vegetation has significantly increased, as marked by the red arrows in the image. Note how this result is also somewhat expected given the distribution patterns of invasive species like Phragmites. This was also a starting point for analysis and identifying the areas of concern. We also had communications with Marley from the Phragmites Working Group of Lake Bernard, and through her information and visual confirmation and secondary data, we created point shape files of Phragmites locations and areas of concern. Moving on.
So now on to image classification. Image classification was done through ArcGIS Pro, allowing information to be extracted from the multi-band remote sensing. With this in mind, for image classification, it uses trained samples that was inputted manually, where the classification is pixel-based, meaning that it looks at the spectral characteristics of each pixel to determine which land cover type it should fit. In addition to that, it also used a random tree classifier, using machine learning to determine what is suitable for what land cover, going through a tree of decision making. So as you can see here, the yellow indicates the removal area, and the removal area was mostly focused on the northern region of this area. And well, the Phragmites are mostly propagated downwards towards the southern region. This could be linked back to how the removal area is mostly concentrated in the north, allowing propagation of the Phragmites in the south.
The GeoScholar Central Ontario Orthophotography Project data from 2016 was used as base maps for proximity analysis techniques to water resources surrounding Lake Bernard. This is an examination of the potential spread of Phragmites using kernel density estimation. Overall, there appears to be a significantly denser presence of Phragmites on the northeast and northwest shore study sites. The strongest trends of distribution are found along the beach of the west shoreline, the dam, and Pool Lake. Moving on, we continued proximity analysis with a buffer analysis to examine potential spread at 500 meter, 300 meter, and 100 meter buffers. Generally, it appeared that if the spread of Phragmites remained under 100 meters, then Phragmites can be prevented from entering adjacent water sources. Overall, the dispersal range of identified Phragmites is most significant along the west shore of Lake Bernard. Overall, there is adequate distribution of Phragmites in each of the identified study sites of concern. One exception to this trend is the northeast study site location with a high mean of 21.5. However, this study site is larger in area as it was surveyed on multiple drone flight patterns. Moving on, we conducted nearest neighbor analysis to examine the distribution pattern over the study area. A summary of the results is shown here. Overall, the spatial distribution of Phragmites appears to be clustered. This is indicated by the low value of the nearest neighbor ratio, 0.296, the z-score value of negative 197.81 is also significant, which confirms that the spatial distribution of this invasive species is not normally distributed. Although they can spread by both rhizomes and seed dispersal through winds, the cluster distribution indicates that vegetative propagation through rhizomes is the preferred method of spread. These results are expected given that other studies have shown that the expansion of Phragmites is more likely to occur directly adjacent to existing stands. Phragmites achieves this type of distribution in habitats with adequate environmental resources that allow them to produce more Phragmites and colonize a larger area. Moving on. This picture is the visible atmospherically resistant index analysis that we conducted on the dam study site area. The Vari analysis is minimally sensitive to atmospheric effects and allows vegetation to be estimated in a wide variety of environments. It is used for RGB data and not NRI data. It is originally designed for satellite use. It is also commonly found in agriculture use due to the lower cost compared to the NIR, drones, and cameras. This index is essentially a measure of how green an area is and is represented by this formula here. And moving on, the other sites we analyzed with Vari were the beach and island sites shown on the beach on the left and the island on the right. It is notable that there is a wide variety of healthy vegetation index values, and but there is a significantly low vegetation area on the southeast shoreline of the island study site. It's noted by this red curve here. I don't know if you can see my cursor. Moving on.
So moving on to the objectives. So what do we hope to accomplish with our research?
Sorry. Moving on, the Vari analysis results summary are shown here in a table with maximum, minimum, and mean values. The positive Vari values are correlated with a healthy vegetation, and in contrast, the negative Vari values are correlated with unhealthy or dead vegetation. The resulting values from Lake Bernard display a negative skew and overall negative average, inferencing unhealthy vegetation. Moving on.
All right, so looking at the Ndvi analysis. So the normalized difference vegetation index is calculated from visible and near infrared light reflected by vegetation. So healthy vegetation absorbs most of the visible light that hits it and reflects a large portion of the near infrared light. These values mostly represent greenness or biomass, where negative values are mainly clouds, water, and snow. Values near zero are rocks and bare soil. Moderate values are mainly shrub and grasslands, while high values are indicators of temperate and tropical rainforests. The index itself ranges from -1 to 1 and is calculated from the equation provided on the slide. Ariana will now explain a little bit more about what these mean through our study sites.
So, as I mentioned before, the eastern coast was used for comparative analysis as a control measure for how an area looks without Phragmites, which is indicated by the map to the right. So as you can see, the forest itself has a consistently high NDVI, so high vegetative health, with specks of moderate/low vegetation health, and the water, which is indicated by red, is of course red as low because it does not reflect outside of the visible light spectrum. While the map to the right has Phragmites present, and as you can see, there's a consistently lower vegetation health at the shoreline, which is where Phragmites are most present, which we can see comparing it to the image classification, which is a correlation of the pink area, which is Phragmites, to the lower vegetation health. In addition, the terrestrial removal area also has low vegetation health, and therefore the recovery of this area should be monitored. Other factors that we would need to consider with NDVI is Phragmites grow really tall, about 5 to 6 feet tall, and therefore can block sunlight for low-lying vegetation or nearby vegetation, as well as they cause changes in the macronutrient pools and fluxes, which can impair or impact the vegetation nearby. Now moving on to our discussion, where we'll go over our challenges and limitation, our overall finding, and what can be improved.
Some of the challenges and limitations we faced was that there was a limited control over the data sampling and collection for the data provided to us. Our analysis focuses on an issue that was also not the only focus during data collection. Originally, the data was collected for physical properties of the lake rather than invasive species like Phragmites. The secondary data was used, thus we could also not correct any data collection mistakes that occurred. There are also limitations using the Windows remote desktop software. Moving on. Overall, the results correspond with the hypothesis that Phragmites locations are increasing while surrounding vegetative health is declining. Visual comparison of the study sites between 2016 and 2019 show an increased presence of shoreline vegetation. Since invasive species are known to rapidly take over ecosystems, new vegetation on shoreline can be assumed to likely be Phragmites. Image classification through ArcGIS resulted in a large abundance of marsh species on the shoreline and small abundances dispersed into forested area. This result supports the hypothesis that Phragmites are spreading outward of Lake Bernard and potentially into other water sources. Several research studies have found the average spread of Phragmites to be approximately 5 hectares per year, if no conservation methods are implemented. The buffer analysis shows that dispersal over the 100-meter range will result in Phragmites invasion to Pool Lake and the dam. Vari analysis resulted in negative average values for vegetative health in each study site, and Ndvi analysis found areas of low index indicating Phragmites are present. Moving on.
So now we'll go over what can be improved both for removal methods and the study itself. So as mentioned before, the main method for dispersion for Phragmites is vegetative propagation, such as wind dispersal, and therefore removal of the plant before dispersal is really recommended for the treatment of Lake Bernard. The areas of highest priority would be the southern shore near the dam due to its potential to spread downstream. In addition to, as we saw with the image classification, there's an abundance of Phragmites located there. The Phragmites working group of Lake Bernard is currently using mechanical methods and some herbicidal methods, which is very limited because Ontario laws prohibit the chemical use around water bodies, but it can be used inland. However, there's no quick solution for eradicating Phragmites where even if herbicides could be used, they can only reduce the abundance of Phragmites for 1 year and they don't completely eradicate it. Other things, what we could do to improve the study is to consider the soil chemical composition measurements because Phragmites have high carbon assimilation rate, a high nitrogen concentration, and high phosphorus concentration, which the nitrogen and phosphorus concentration increase more so during its growing season. And knowing when this growing season occurs would aid in reducing the dispersal. Moving on to our conclusion.
Overall, the Phragmites locations are increasing while surrounding vegetative health is declining. Increasing human development on Lake Bernard will likely create ideal conditions for the spread of Phragmites by reducing competition with other plants and further enriching the soil and water with nutrients. To reduce this, more conservation measures should be implemented. For future studies, a more comprehensive examination of the spatial and temporal distribution of invasive Phragmites is recommended to understand the rate of spread and the factors that influence it. However, the Vari and Ndvi analysis resulted in a negative average that implies the vegetation surrounding Lake Bernard is unhealthy. Ndvi specifically indicated the presence of Phragmites will significantly impact the vegetative health of residing species. Readers should be cautious that data from this study was collected in 2019 or earlier, therefore the data may not represent the current state. Additionally, the methods used are also subject to error. Moving on. Thank you guys so much for listening. Does anyone have any questions for us? This was also our poster that we created for our course. It kind of summarizes our presentation.
All right, thanks so much for the presentation. We'll now move on to answering questions and responding to any comments you may have. As a reminder, please use the chat box to submit your question or comment. So I had a comment for a question/comment for you guys. In your analysis, you said that the distribution of Phragmites is not normally distributed within the lake area. Is there any other information? I know you talked a little bit about soil chemistry. Is there any other information that you wish you had from your secondary source that would have helped any analysis of distribution?
It would have been useful if you could take on the other physical characteristics of the environment, such as how, like weather, so wind, as mentioned before, because wind dispersal is a big way it distributes. In addition, knowing like human impacts such as construction. So if there's a lot of construction, there has been a study showing that in Montreal, that a lot of seeds would get stuck in between tires of construction like vehicles and would allow it to distribute farther. So understanding that would be helpful. And if there's anything else my members want to add?
Yeah, I just had a point. I wish that COVID didn't restrict us to being virtual. I always wish, we could have done some physical sampling, like soil sampling and just ground sampling, actually getting an accurate species count of, accurate population numbers for that. I thought would have been a bit more helpful, but you do what you can with the restrictions, so everything's good.
And for the question in the chat, I can definitely email the poster to the Lake Bernard's Phragmites Working Group.
All right, do we have any other questions for our presenters today? I guess another question I would have is, you talked about some spread into other water bodies. Are there avenues and pathways for that within this area through hydrological pathways? Is there a lot of surrounding water bodies?
There is not too many, like close by. Pool Lake is right there, and the dam is right at the south shore as well. So it's just a concern for mostly on the dam, especially for spreading it further out past, I don't know if anyone has anything else to add to that.
I can actually pull up the map and show everyone, because you can see Pool Lake about right here at the corner, the southeast corner, as well as there is a little bit, there's also the dam, which is highlighted in pink, as Brianna mentioned, so this shows the spatial distribution of everything.
Yeah, maybe if you pull up one of my maps, either the buffer one, maybe, that one kind of is a bigger, widespread, shows broader a little bit. Okay, maybe not. It's kind of cut at the bottom. Sorry. Yeah. Yeah, the dam was our main concern for waterway spread into other sources, though.
Looks like we have another question in the chat. The Almajuan Highlands, if I'm saying that right, includes many lakes in the East Parry Sound area. Would there be a possibility of doing this elsewhere?
Well, these methods could easily be applied with the use, but Vari can easily be applied to RGB imagery, which is much easier to obtain than NIR, as well as, so these can easily be applied, and we would gladly do it because this was really fun to do and to understand and do research to understand this actual problem. If any of my other members have anything to add.
No, that sums it up for me. Yeah, I was just, I know, Vari and RGB aerial imagery is huge in agriculture for measuring the crop health for farmers. So that's definitely applied easily for methods like that. There are a couple other questions there.
Yeah, we have a question from Matthew Clayfield. What are some of the consequences of losing natural plant life and having it be replaced by Phragmites?
Well, the consequence of losing it causes a chain reaction because of the food chain, right? There are a lot of species that rely on the native vegetation as a food source, and they can't rely on Phragmites to consume, and therefore you lose a lot of native species outside of vegetation, which then impacts everything else. It causes a chain reaction because one species being affected will affect another species.
Mm-hmm. It also affects the soil chemistry composition. The nutrients that are there impacting the other species living in the area. And so it's not just getting rid of the marsh, like shoreline species, it's spreading into the rest of the forested vegetative health.
All right, and we have another question by from Jimmy Thring. Can Phragmites be used for plant-based products, so harvested for a purpose?
Well, they can be because harvesting can lead to the accidental distribution of it, it's a risk to use it as a plant-based product because you can accidentally cause it to invade another area. So it's not worth the risk, as well as you would have to consider the high concentration of nitrogen and phosphorus, which phosphorus in nature occurs at a very little amount, so having an overdose of phosphorus can cause an impact on the other plants. So there's a lot of consideration with that, and it wouldn't be worth the risks.
As for uses of the plant, I haven't done much research on that, but I do know that there are some medicinal value to it. However, I would have to do more research on that to let you know more in detail. But it looks like Phragmites has been used medicinally as remedy for arthritis and fever and some other problems like that.
We have another question from Bob Bowles. Did you do any studies on the interaction of native turtles in the lake and the effect of the Phragmites stands?
We did not look into turtles as one of the factors to consider. We mostly focused on, because we were limited to the drone imagery, we could only be able to pick up vegetation. So knowing where turtle population is cannot be depicted from the maps we had. But we didn't do any research onto turtles itself. We mostly focused on how can vegetation be impacted by Phragmites and how Phragmites are able to invade so easily and stay there, because they are a pest and they are tricky to get rid of.
Yeah, one of our initial research proposal ideas was to look at the correlation and the relationships with the invasive Phragmite species and how they've been impacted or affected or influenced by human development, the other species in the area, the aquatic species, land species, but just due to the restricted data we had, that would obviously be another potential research build off of this project, though.
All right, do we have any additional questions? We have a question of why are Phragmites so difficult to remove?
So if we look at the morphological traits of Phragmites, you can, a lot of studies have found that 80%, typically 80% of their biomass is within their root system, and their root system is a tangled mess. And to be able to fully remove Phragmites, you would have to get it from the roots, which is super tricky to do when it's a matrix.
All right. Well, with that, wraps up our webinar today. Thank you so much, Brianna, Jacqueline, Mariana, and Ida. Thank you for your great presentation and sharing your work with us today. If you have any questions about the team's work, please reach out to them for more information.
Thank you so much for having us.
Yeah,
Absolutely.
thank you so much.
A recording of the webinar today will be shared out through Eventbrite and will be available on the website next week.
Awesome. Thank you so much. That's great.
And our next webinar is on May 12th. Ray Robinson from Utah State University. So you can register for this as well on the GLPC website. Thanks for watching. I do want to acknowledge the U.S. Geological Survey and the Great Lakes Restoration Initiative for providing funding support for the collaborative. As a reminder, the webinar recording will be posted in the next few days. And if you have any additional follow-up or questions or comments, please feel free to contact us at our email, phragmites@glc.org. All right, thanks again, everyone, and have a wonderful day.